Welcome to Advanced Debugging Techniques, part of our Applitools in Action series. I'm Pam Morgan, and I will be the session host. I'm joined today by my colleague, Sharon Cedas-Weiss, a customer success engineer here at Applitools. With more than 12 years of experience in the industry, including various R&D and customer-facing roles, Sharon leverages their knowledge, technical expertise, and enthusiasm for quality to support and guide our customers. Their ability to take a bird's eye view helps customers fine-tune their testing strategies.
Thanks for joining. I'm very much excited to be here again in this series of Applitools in Action. And today we're going to discuss advanced debugging techniques. So as a former developer myself, I know and understand how much you probably struggle with debugging, especially when it comes to testing and the flakiness aspect that gets into this equation. So let's see how we handle that with the Applitools Intelligent Testing Platform. First and foremost, a quick recap. With the exponential growth in complexity and scale, teams just require to just reinvent themselves. So basically, we need to support more and more pages, the release cycles becoming more and more frequent, the complexity of the scenarios and dynamic flows are becoming more and more complex over time. Environments that we need to support, with device proliferation in the market today, are becoming a tremendous challenge for organizations. And of course, it all comes down to doing all of that with much less time and money spent, resources, basically. And the main challenge here is that traditional testing platforms just cannot scale to these challenges. You cannot test with Selenium, Appium, Cypress, etc. Platforms that are becoming so complex and need to support dozens of thousands of screen combinations. You need to support also languages and locales and the rapidly evolving applications. And bottom line, you will either need to compromise on the coverage, or you will just need to pay in costs, time, and delays of your releases. And for that purpose, we invented the Applitools Intelligent Testing Platform, a one-stop shop AI-powered on every stage of the testing lifecycle, starting from authoring through validation, execution, and then the analytics part. So that's just a recap if any of you did not participate in the previous sessions. Let's talk debugging. So when we actually zoom here, we're going to zoom here in the execution and analytics part. And when we're talking about debugging, what would be the main friction points? When and why do we need debugging at all? So first friction point would be a broken test. Clearly, if a test breaks, we will need to fix it. That's a number one case that will require debugging. After a test breaks, second factor here is analyzing the root cause and fixing the broken test. So these two factors together combine to a lot of friction points. And we would naturally want to reduce both factors, both the amount of broken tests and the time it takes to fix those. So in terms of the reason for the break, now maybe you saw already in the chat, Pam just shared a poll with you, and I'm very curious to hear from you which factor of these four, which we're going to focus on today, affects the most on the flakiness of your tests. Either applications that are evolving so fast and you need your testing platform to always adjust to those rapid changes. Is it device proliferation that requires you to test your application on dozens of different devices and screen sizes and responsiveness? Is it the complexity of the testing environment, which require different aspects, different platforms joining together, starting from networking through security, CI, the actual testing platform, and its dependencies, and of course, your code, your testing code, which is just a little part of the whole mess here that can cause a lot of friction and involve multiple teams in the analytics and fixing part? Or is it broken locators? The test the applications that are evolving so fast can eventually break your tests, since developers may do some changes on the application that will eventually break your test, for sometimes for no reason. Even if the test and application looks just as expected and the functionality works as expected, it can still break. So I hope you answered the poll. Pam, do you want to share the results? So applications are evolving fast. That's number one factor. That's great to hear that. Broken locator is number two, or no, actually that's number three. It's not ordered. Complex testing environment, I completely agree. And device proliferation, surprising, only 5%. But thanks very much. This is really helpful. Okay, let's start with talking about the broken locators. One quite a main factor here in the poll, as I saw earlier. And the way we want to handle this is by just help you self-heal your test. So please meet the world's first self-healing Selenium grid. And this magician here will actually execute your test. That's a testing execution platform designed for scale and resiliency. And it will also self-heal your test. And what do I mean by that? How can we heal a test? What breaks a test? So from our experience and from our research, the test is like this testing script over here is combined either by page interaction with a page, either navigating to a page, locating elements, clicking on elements. These are the two yellow lines here. Between these lines, we're usually going to perform some verification or validation steps. In the old world of testing, usually these verification steps will require interaction with the page as well. Like with Selenium, you will like to grab some element and then do some verification steps on it. But in the new world, this is an example that that has eyes check command integrated. Like eyes, this is our product for visual validation, visual testing. So that's a one-liner, one code that will cover your whole page with a screenshot without any dependency whatsoever to your page. So this is another factor that will reduce friction, so much less interaction with the page. But you still need to interact with the page, because you do need to mimic the user actions on the screen. And we've found that the flakiness usually comes from those interactions with the screen, not the verification. So look at this example here. What if a developer changes the ID from the correct ID to a wrong ID? That's just a div example here, and the wrong ID could also be just a new ID or some other change of your application. So then you'll get a no such element exception. Your whole CI will break, many teams will be affected, a lot of mess, and then you need to start investigating this. So what are we going to do? We will actually self-heal your test. We're going to look at the selector, the failed one, and we're going to search for you for another alternative way to find this element on the screen. And once we did that, we're going to also display the results to you on the UI. So that's both reducing the reasons the test would break. So we actually self-heal the test, nothing to your concern. This would be automatically healed. And also we help you analyze and even improve it, fix it, change it. We direct you exactly to where things went wrong and what you are better do differently. So the execution cloud is so robust that it would also heal your test in case the elements attributes are changing, the text is changing, the DOM position in the hierarchy change. The size and location of the element is changing. And it's gonna learn this mechanism over time. So this is an AI-based mechanism, evolving and learning your platform over and over, and on each test execution. So this is actually a real magic here, because you get your tests perfectly perfectly adjusted to the real world, and the mechanism will only get better for you as time passes. The execution cloud is not only designed for healing, it's also designed for scale. It will give you a parallel execution platform, including the self-healing, functional and visual validation. That means that you don't have to use visual testing at all. You can just use classic Selenium approach, and you can integrate these tests into the execution cloud. That's called, if I didn't mention earlier, that's the Selenium grid is called execution cloud. So this cloud platform will allow you to execute any Selenium test on it, as well as different languages, different programming languages, anything that supports Selenium or WebDriver IO. I will also show you in a second how you can see the video of the actual execution, including console logs and WebDriver logs, which are crucial for debugging. It's other debugging aspects. Easy migration, that's a one-liner of code to just redirect your tests to our cloud instead of any other platform you used to use. So let's do a quick demo here. I'm going to show you a test that, by the way, this is the Applitools Eyes platform. You can see here, if I'm switching to the visual mode, and you can see here a screenshot of a web page that's just a login form, and then after login, we can take a screenshot of the home page. This is completely pure demo application, and we're going to see what happens if we try to break one of the selectors. So if I switch to the Java code and switch to the presentation mode, I'm going to show you a code snippet, which is a very basic one, which includes the configuration of the eyes object. So that means we're going to take screenshot in this flow. And basically, the driver initialization would just require you to, in line 57 here, to redirect your driver to a remote web driver into our URL instead of a classic Chrome driver in line 60. So this is only difference, and you can see how easy it is. And then what I'm going to do next is tweak the URL with a JavaScript code, just like you see here. If I run the test with Execution Cloud, EC, I will just search for an element called the username. We're talking here about the login page I showed you earlier, and I'm going to change its ID to a new ID. I'm just going to simulate a situation where development team changed the ID of the element. And then what I'm going to do next in line 75, I'm going to search for this element based on the old attributes and actually fail. And then we can see how this test would be healed. Let's execute this test. And meanwhile, we can switch back to the dashboard side. It's a good opportunity for you guys to prepare the questions if you have any. Put them in the chat, and I will shortly answer all of these questions. Okay, let's give it some time. Okay, it's running. Okay, so it's almost completed, but we can already see that one test, 1 out of 3, so that's actually the same test executed on 3 different platforms, has completed with a self-healing mechanism that was successfully able to fix this test. As you can see here, this icon means that we managed to heal your test. We can collect also statistics about this, and we can see that a really nice percentage of tests being healed by this mechanism. So when we click this this icon, we can easily see that the original selector, the username, was failing to find the element, and we replaced it with whatever other attribute. And again, it's always evolving and learning your DOM over time. And in addition to that, I promised to show you logs and video recording, so we can also see a video or recording of this test execution based on the screen size that you selected. And you can also download the screenshots, and you can also download WebDriver commands log and console logs. I don't want to download it right now. I'm going to just show you an example I downloaded earlier. And this is how it's going to look. Very helpful. You see it here that we failed to load a resource based on a status 404. And the WebDriver logs are here. So this could be very helpful for debugging. And that's a good opportunity to pause for questions if we have any.
Yes, we have a couple questions. I'm going to bring them on the stage. So the first question is, how can we handle an auto-generated ID within an element?
That's a really good question. So we basically don't rely, when we self-heal your test, we don't only rely on the ID. We rely on all the different elements. So if there's any element that is dynamic, auto-generated, or something that is not reliable for the sake of this test, we will just find other attributes which are more robust for this purpose.
Okay. Next question. How does the tool know which element we are referring to after the change in DOM structure? Does it contain history of the DOM content before or after the changes?
This is also a great question. So this is an AI-based mechanism, and it's designed to learn your DOM structure. So we are not only going to rely on attributes, we're going to also rely on the hierarchy of that DOM, and we're going to just learn it over time. And this mechanism will improve again and again as you start using it. So we do expect you to see an increasing percentage of healed tests over time. That's an AI-based mechanism.
And one more during this break. Does self-healing work with TypeScript and Playwright?
Well, currently it's only Selenium and WebDriver IO based, and any other platform which is Selenium based. In the future, we might support other platforms as well. Next topic, device proliferation. So what happens if if we need to support multiple devices, and let's see what are the challenges we have here. So in just one word, let me explain about the ultra-fast grid. That's our platform for cross-browser testing. I'm going to say a few words about that so that we can deep dive. So the ultra-fast grid is our solution for cross-browser testing. The way it works makes it so fast, sometimes even 18 times and more faster than traditional execution clouds. And this is a real game changer. We've seen that dozens of times with our customers. And let me explain how it works. So usually classic approach would go and execute your test on whatever platforms you want to test on. And by a platform, I mean a browser, the viewport size, the device, the operating system, etc. So if the test takes, just for simplicity, 1 minute to execute, then 10 platforms would take 10 minutes. The magic of the execution cloud is the ultra-fast grid, is that we don't execute your test 10 times. We execute it only one time, and at the point of time where you want to validate your page, like taking a screenshot with eyes, We only grab the HTML, CSS, and other resources of that page and render that remotely on our Ultrafast Grid cloud. And that's basically just dumping this URL, this HTML, to a remote browser. We support up to 2 versions back, and the magic here is that instead of these 10 minutes with other platforms, it would probably take somewhere between a minute and a minute and 10 seconds if we're talking about 1 minute of executing one test. This is a real game changer. But what happens if only one test, like maybe a Firefox-based test, would break? Only one out of all the others. How can we debug such a case? This is such an edge case that we see very commonly among our customers, which makes things harder. But with our platform, you can actually get the root cause analyzer. And this is the panel that you can see here on the left side. So if we're going back to ICE dashboard, where you can see the expected state of the page, which is the baseline, versus the actual state of the page, that's a screenshot that we compare, that's the visual testing, AI-powered visual testing, then you might be wondering, why is this image missing for Firefox? Here is his Firefox, and it's not missing for any other platform. So you can just open the root cause analysis panel, and you will see here on the left side comparison on the DOM level and CSS level of exactly what went wrong. You can control this. You can navigate through this button that you see here, through this whole page, and see exactly behind the scenes what went wrong, or what differences do you see there. So we can easily see that the image got broken, and now in the CSS style it doesn't contain any image, and this is why it broke. And in addition to that, even if there are no visual differences whatsoever, you can still navigate through this left side panel and find all kind of differences. Like, let's say, for example, a common use case by our customers is how do you validate like a link? Like, you want to make sure that the link contains the correct URL. And if it doesn't, then you would know there is no visual differences. That's the same link. But if you open this panel, then you can see what links exactly you have behind the scenes. And of course, any other use case you can think of. And with this technique, we actually reduce the time it takes to analyze and fix the broken test. So this is the second factor we talked about. And for the next topic, that I think you chose this as a number one cause for friction, and I can so much relate, is that applications are evolving super fast. And what I want to tell you about this is that the number one technique to solve this is prevention and not debugging. Like, of course, debugging tools are very helpful, but what if we prevent the broken tests in the first place? And tests now will break basically the same amount of times, but you will not need to change your code. So basically what happens when an application changes, you need to go to your testing code and adjust it based on the changes, either to add a validation or interaction with the new element, or remove some code, or just address it differently. So there's a coding work. This is very expensive in terms of resources. What we do differently is just thumbing up and down. So we go for the visual approach, and then you can actually see the differences with your eyes. You don't need to run a test script, then make sure that you understand what changes were there. You get probably a broken test, and then you need to start analyzing and investigating. So instead of offering a really, really good debugging tool for this purpose, we just prevent the need for debugging in the first place, which can help you even more time. So once there's a differences that are accepted by you, all you need to do is to thumb up a new baseline. Then you don't need to execute your test again. So look at the previous approach, look at the old approach. You will need to change, you need to analyze, first of all, analyze what went wrong with the page, a broken test, then you'll need to fix the test, and then you will need to execute it again. Now you don't need to analyze because you see that with your eyes. You don't need to fix any code because you can just thumb up or down to accept those changes or decline them. And you don't need to execute your test because if you accept or decline a test, then the next time the baseline is changed or remain the same, and this will not impact any of your test results. You can actually adjust the status of the test right from this panel. And moreover, what happens if this change is going all the way through on different platforms? So back to our shoe store example, we can see here that we can use this button here, which is called, which is part of the auto maintenance mechanism, which is very advanced here at Applitools. It will allow you to group any step that includes the exact same differences of the evolving application, the exact same new feature or a new bug that maybe was introduced. And this is how you can rapidly respond to those changes. And I see that 48 of you, percent of the audience here just mentioned that this is number one for flakiness. So look how easy it is to handle this. I hope you're still collecting your questions on the screen. If you didn't have a chance to understand what's going on here, you can see here there is a pile of images which you can now thumb up or down based on whatever action you want to do as a bulk. And this will also save you time. And last but not least, the complex testing environment. So when we're talking about complex testing environment, again, let's go for the classic approach versus the Applitools approach. So the classic approach, you will probably have a lot of actors along the way. So that's so a test could break due to networking issue, security or firewall issue, CI, Jenkins, or something of that type. The testing platform, like I don't know, JUnit or any of those, and also the actual code, your actual testing code. So that's only just the tip of the iceberg. You would expect that you need to maintain only your testing code, but there's a lot of other players in this equation. And this makes the analytics part after a test breaks much more complicated. There's many teams involved. That could be DevOps people, that could be developers, that could be the QA engineer, like the automation engineers, and more and more. And then when something breaks, you need everyone alerted and on their feet. So how do we do things differently? Tool consolidation. We actually created a platform, and we're back to square one, where we started with the actual testing platform. Our one-stop shop testing platform is basically one source of truth. It allows you to author, validate, and execute your test on our platform. Not only that you do that on our side and we take responsibility for what's going on behind the scenes, then you don't need all the teams to be involved. You just need one team that works with the platform to be involved in any breaks of the test. And as not only that it serves as one source of truth, it also gonna help you with less friction, less breaks, because our platform was designed for testing, unlike other tools which are not natively designed for testing. For example, Jenkins is not a testing platform, it's just an execution platform. So our platform is designed for that. So the whole mechanism of Execution Cloud and Ultrafast Grid is designed for stability. So again, we're trying to reduce the amount of friction, both by reducing the amount of test breaking and also the analytics part, which again will be only with the people involved with this platform and no other teams, and again, we want to reduce the noise in the system when a test breaks. We want to reduce this mess when everyone is on their feet. I hope I was able to give you a glance of where and how we do things differently, and I hope you could relate, at least to some extent, with the mechanism of prevention of the flakiness as well as improving the analytics tools. That's it. Questions? Do you have any other questions? It would be a delight for me.
Thank you, Sharon. Thank you for a great presentation. We do have a few questions. I will bring these to the stage. The first one is how self-healing works when object identification is failed.
That's a great question. The name is Nagaraju. I hope I pronounced it correctly. Thank you, Nagaraju. So self-healing will do its very best to heal your test, and if it fails, it will just go ahead and break your test. And of course, the root cause analysis would be a backup mechanism for you to understand exactly what went wrong.
Okay. And then earlier in the chat, Eon asked how to deal with flaky tests.
How to deal with the flaky tests? Okay, this is a really good question. So if we're talking about the world of visual testing, Applitools offers a vast amount of tools and best practices in order to reduce flakiness and increase your pass rate. As higher your pass rate, that's how more reliable your testing suite. And nothing is more important than making your testing suite reliable, because then it's usable, then it's efficient. So we use all sorts of tools I just showed you. I focus on debugging tools, but we also have a pack of other approaches by like marking flaky areas on the screen. If we're talking about, of course, visual validation, marking them as either ignored, or maybe we want to mark them as dynamic, so that maybe the flakiness is caused by dynamic content. That was part of the previous session we had in this series. You can go and see the recording there. And other tools I can get in. I can talk for hours about this. So the auto maintenance and other aspects. Maybe we can address this in some other session in a deeper dive. But that's a really good question. Thanks for that.
Excellent, excellent. I see another question about maintaining a visual difference across multiple browsers. How do I maintain a visual difference across multiple browsers?
So the way you do that is using the auto maintenance, which I showed you earlier in a glance. And the auto maintenance mechanism has much more into it. It's also going to help you with a bug marking, so that the bug would still be marked as the test continues to fail. So again, we're trying to reduce the amount of maintenance work you need to do. And the ultra-fast grid and its capabilities to stabilize a test. By the way, I didn't speak a lot about that, but I see that the flakiness aspect is very interesting for you. So this is really good topic, because we can address other techniques that we use to reduce flakiness. So the ultra-fast grid, which I explained earlier, we also stabilize your web page. So we don't only just dump this HTML on other browser, on a remote browser on our side, we also stabilize it. So we pause videos and animations, and we do all kind of stabilization phases so that it will always give you an accurate result with less flakiness.
Excellent, excellent. All right, audience, you've got just another minute to add questions for Sharon. Please add them to the Q&A tab so that we can share them with the group. But Sharon, I have one more question. How do you support responsiveness on the ultra-fast grid?
That's another great question. So basically, responsiveness would either be based on the CSS styling, which will be responsive to this page size, or that would be based on JavaScript. Either way, we're going to capture this with the ultra-fast grid. We can either just resize your page so that the CSS styling changes would, of course, be reflected, and then we take a screenshot. And the other aspect is that we will take the DOM for any different screen resolution. So that's the second approach, and that would support the JavaScript flakiness if there's any aspect of JavaScript into the responsiveness mechanism.
Great, great. All right, we've got two more. Myron asks, what can we do if the test fails in the production environment, but we are not able to reproduce it locally?
Okay, that's a good question. So in terms of production versus local, we're gonna probably help you with the best practices to understand. Again, the root cause analysis tool will help you find the problem on production, and the local test will. It could also, by the way, be vice versa. The local test could break while production is not. We always want to try to help you find the root cause of what exactly went wrong. And we're trying to think of many aspects, not only coding aspect, it could be environmental aspects. So if it helps when it comes to production versus locally, if you go with our platform, which is, again, everything, it's a one source of truth on our side, it will be much easier to understand where things went wrong, because the platform will interact with you and explain quotes what exactly happens. So basically, we're trying to reduce the amount of friction. We want to help you align local environment with the production environment or CI environment, if that helps.
All right, great. We have another one. Let's see here. Are there any accessibility tests incorporated?
Well, yes, this is a really good question. So we have an accessibility tool. Let me show you how this works. I'll share the screen just for a second. Okay. So in terms of accessibility, let's make it larger. Okay. Look at this Yahoo Finance page, and I'm just gonna open the accessibility panel. And thanks for asking this question, because I do see how you see that as related to debugging, or just debugging the accessibility aspect. And what we're going to see here is that you can select the WCAG version, either 2.0 or 2.1, and the level of strictness, AA or AAA. And then we're going to do two things here, both classify the object, since this standard is based on the object type. So graphical object has other specifications than other types like text or other types of objects. A large text, a small text, this is based on the WCAG standard. And once classified, we're going to also show you the contrast differences in if you passed them or failed based on the standards. And of course, you can see here that with AA versus AAA, we found much more violations.
Thank you, Sharon, for an excellent demonstration. And thank you everyone for who joined us today for your questions. We hope you found today's session insightful. If you missed any of the other sessions, dashboarding best practices or test automation for dynamic applications, you can watch them on demand at applitools.com/resources. We are going to be bringing additional sessions in the Applitools in Action series to you soon. Please stay tuned for that. As a pioneer and leader in AI-powered automated testing for the enterprise, Applitools aims to make intelligent solutions accessible to all and to deliver unparalleled business value for our customers around the globe. If you are an Applitools customer, reach out to your account team to learn more about how you can take advantage of these strategies outlined today, or to try the Applitools Intelligent Testing Platform. And if you're not yet an Applitools customer, you can see firsthand the power of leveraging AI in every stage of the testing lifecycle by signing up for a free trial. Again, thank you for joining us. We hope to see you again soon.